Hello friends, welcome to lecture number 20 of complex analysis. Today we are going to solve problems based on Laurent series. Okay, so before you watch this video, watch the previous lecture number 19. Okay, and all the links of the previous lectures are given in the description box. So if you haven't watched, then please watch all of them one by one from lecture 1 to 19, then watch 20. Okay, so before we start, please subscribe the channel, hit the thumbs up button if you like my videos, and also share with your friends. Help me to grow my channel and inspire me to create new contents for you. And if you are new to my channel, please subscribe it. Okay, and if you want to follow me, you can follow me on Insta. Here is my Insta ID. Let me show you. So this is my Insta ID, Lakhyajit123. Okay, you can follow me on Insta as well. So now let's solve the first problem. So here is the first question, and we need to expand this one. So I miss one thing. So here we need to expand this function in Laurent series. So these are the conditions. This is A, this is B. So series will be different for different conditions. So what we're going to do first, so let me write the given function here. The given function f of z is this. So let me copy the function. Okay, so here is the given function. Let it be f of z. Okay, so first we're gonna factorize it, and we're gonna write this one in this form: a by z plus 1, then plus b by z plus 3. So we're gonna use partial fraction first. Okay, so then we're gonna apply these conditions. Right, so here you see you must know two very important expansions, binomial expansions. You must know these two. That here you see, let me reduce it. So 1 plus x to the power minus 1 is 1 minus x plus x square, then minus x cube, then plus x to the power 4, then minus x to the power 5, and so on, dot dot dot. So again, 1 minus x whole to the power minus 1, that's going to be 1 plus x square plus x cube plus dot dot dot, so on. You must know these two results. Okay, so first what we're going to do, so let's find a and b if you use partial fraction. So it's very simple here. Let's see, just if we take LCM z plus 1 into z plus 3, so then here we're going to have a into z plus 3 into a, then plus b into z plus 1 into b. That means simply b, right? So here we can write what we can do here, we can take z common from these two terms, right? So let's take z common from these two terms, then a plus b into z, we're going to have a plus b into z, and we're going to have a constant part, that is 3a and b. So 3a plus b, this is going to be the constant part, divided by again z plus 1 into z plus 3, right? Now here you see, if you compare both the left hand and right hand side, z plus 1 into z plus 3, right? So here we can write this denominator as 0 into z plus 1, right? We can assume that way. Then if you compare the coefficients, then a plus b must be equal to 0, right? We don't have to show all these things, right? So here what are you gonna get? So if you solve it, then you're gonna have a plus b equal to 0, and as I have already told you, we can write the numerator as, so here you see a z plus 1 into z plus 3, as you can write the numerator as 0 into z plus 1. So here 1 is the constant part, that means this a plus 3a plus b part is that's going to be equal to 1. Comparing the coefficients, we're going to get 3a plus b, that's going to be equal to 1, right? So now you see, from this one, here we're going to have a is equal to minus b. Let me use that value here. then what we're gonna have, minus 3b. So let me write it properly, minus 3b, then plus b is equal to 1, and that's going to be minus 2b, and that's going to be 1, so b going to be equal to minus 1 by 2, right? Minus 1 by 2, that's what we're going to have. Then if we use this value here, then it's going to be a is equal to minus 1 by 2, that's going to be plus half, right? So hope you have understood this. So now that's why we have got the value of a, which is equal to half, and b is equal to minus half. So we can write the function f of z as this way. So here what we have got, a is equal to half, b is equal to minus half. Sorry. So therefore the given function can be written as f of z is equal to half by z plus 1 plus minus half divided by z plus 3. That's how we can write. Okay, so hope you have understood this. So now what is the next step? Here you see, so now we are going to apply the condition. So what is the first one? So a, yeah, what we have, mod of z is greater than 1 and less than 3, right? So now you see, if you consider the first part, that mod of z is greater than 1, 1 is less than mod of z, or z is greater than 1, same thing. So then we can say that 1 by z mod z is less than 1, right? So we have to make it less than 1. So that means in order, we are going to use this expression here in the denominator, and we're gonna make it so I'm gonna explain it again. So now you see 1 by 2. So in order to obtain this 1 by z, we can take z common here from this denominator. If you take z common, then you're gonna have 1 plus 1 by z, right? And so our motive is to make it, less than 1. So that's why we have done this part. So now you see, this can be written in this way. So 1 by 2, this z can be written as z to the power minus 1, and here we're going to have 1 plus 1 by z means z to the power minus 1, z to the power minus 1, then whole to the power. If you write with the numerator, then it's going to be minus 1. Now it is plus 1. When you write here, that's going to be minus 1. So here you see, so before here, now we can apply this identity. So before you apply it, then you make sure that x is less than 1. That means this term here, you are writing z to the power minus 1 instead of x. If you compare with this expression, so you have to make this less than 1. Okay, so doesn't matter whatever you take here, z to the power minus n or z to the power something, that must be less than, or z, it may be 2 by z by 3, something else like this also, depending on the expression. So hope you have understood this. So now similarly, this part here, you see, from this part what we should take common. Now you see, if 1 by z is less than 1, and if you see from this part, here we have two parts in this condition, and the another part is, so let me write here this one. Another part is that mod of z is less than 3. So dividing both sides by 3, mod of z by 3 is less than 1. So here you see, from this, if you take 3 common, okay, then what you're going to have, minus half. On taking 3 common, you're going to have z by 3 plus 1. Instead of writing this way, let me write here 1 plus z by 3, right? So remember one thing, that this part must be less than 1. That's it. Okay, so now you see, just wait, let me little bit of arrangement here. So this is minus, this is plus, so it's gonna be minus half. Then here we have 3, so it's gonna be 6, right? 2 3 is 6, that's gonna be 6. Then 1 plus z by 3 whole to the power minus 1. That's what we have got, right? So this is our f of z now. So let me copy these things and let me go to the next slide. Okay, so let me take a new slide here. So this is the f of z for the first condition. So now let me expand this half z to the power minus 1. If you expand it using this formula, that 1 plus x whole to the power minus 1, which is equal to 1 minus x to the power 1, then plus x to the power 2, then minus x to the power 3, then plus x to the power 4, then minus x to the power 5, and so on. And if you expand it using this formula, 1 plus z to the power minus 1 whole to the power minus 1, then it's going to be 1 minus, here z to the power minus 1 is the x here, then plus z to the power minus 1 whole square, then minus z to the power minus 1 whole to the power 3, plus dot 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 so on. So it's gonna give you 1 minus z to the power minus 1 plus z to the power minus 2 minus z to the power minus 3 plus z to the power minus 4, right, and so on. That's what we're gonna have. So let me write here 1 plus sorry, not plus, minus. So 1 minus z to the power minus 1 plus z to the power minus 2 minus z to the power minus 3 plus z to the power minus 4, then minus dot 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 so on. Then again let me clean these things. So hope you have understood this. 1 by 6. Then if you expand it using the same identity, then you're gonna have, so just okay, 1, then minus z by 3, then plus z squared by 9, then minus z cubed by 27, then so on. That's how it goes, right? So now what we can do here, so we can keep the answer in this way. This is that's our answer. We can keep it here. This is the required Laurent series, right? So hope you have understood this. Okay, now let me go back to the previous slide. Here is the next condition. Here you can see z is greater than 3. What if z is greater than 3? So again, let me, so here you see, let me copy this. Okay, so now we're going to deal with b. So function, this f of z, after partial fraction we have got this, right? So now what is the condition b? That is mod of z is greater than 3. If so, then what we're going to have, 1 is greater than 3 by mod of z, sorry, 3 by mod of z. So if 1 is greater than 3 by root mod of z, so we can say 3 by mod of z is less than 1, right? So hope you have understood this. So now what we can do here, now you can see that, so from this term we can take, if you take z common, then you're gonna have 1 plus 3 by z. But from here, if you take z common, then you're gonna have 1 plus 1 by z, right? Now you see one thing carefully. If 3 by z, if 3 by mod z is less than 1, then obviously 1 by mod of z, that's gonna be also less than, is obvious, right? So if this is less than 1, then 1 by z must be less than 1. So it's it is a common sense, right? So now let me clean these things. Just wait. Okay. So now you can see here that right. Let me write this one here. 1 by 2. So just wait. 1 by 2. By, let me take z common here, and it's going to be 1 plus 1 by z whole, then plus minus, that's mean my 1 by 2, 1 by 2, just wait, and let us take z common. Here it's going to be 1 by 3 plus 3 by z. That's what we're going to have. So now it can be written this way: 1 by 2 z to the power minus 1 plus 1 by z can be written as z to the power minus 1, then whole to the power again minus 1, right? Minus again 1 by 2 z to the power minus 1, then 1 plus 3 z to the power minus 1 whole to the power minus 1. So again we're going to expand these two results, right? If we expand these two results, what are we going to have? So then we're going to get 1 by 2 z inverse can be taken common from these two, right? So if we do so, then let's expand it. Then what are you going to have? 1 minus z to the power minus 1, then plus z to the power minus 2, then minus z to the power minus 3, then plus dot 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 so on, then again minus. As there is minus here, you can see minus, this part is taken common. Now let us expand it. So what you're gonna have, then 1 minus 3 z to the power minus 1, then plus 3 square 9 z to the power minus 2, then minus 27 z to the power minus 3, right? And plus dot 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 so on, right? So that's what we're gonna have. Okay, so now if we open this bracket, this one is open, let us remove this bracket, then this minus sign gonna be plus, plus gonna be minus, minus gonna be plus, right? And so on. So let me remove this bracket. Then what we're gonna have, this minus gonna be plus, then this plus gonna be minus, right? This plus gonna be minus, and this minus gonna be plus, and this plus gonna be minus, right? So hope you have understood this. Now this minus 1 and this plus 1 cancels, right? So this is minus 1, let me write this one here. So this one and this one gone, right? And sum of these two, 1 by 2 z to the power minus 1. So sum of these two, that's going to be 2 z to the power minus 1. Then sum of these two, that's going to be minus 8 z to the power minus 2. Then sum of these two, that's going to be plus 26 z to the power minus 4. Then minus and dot 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 so on. That's what we're going to have. Now let us multiply this one with all the terms. Then what we're going to have, we're going to have here 2 going to be cancelled, then z to the power minus 1 into z to the power minus 1, that's going to be z to the power minus 2. Then again 2 cancels 8, gives 4, right? So we're going to have minus 4 z to the power minus 3, right? Then we're going to have plus, and if you 2 cancels 26, then it's going to give you 13 z to the power minus 5, and so on, right? Sorry, I missed something. That should be 3 actually, that should be 3, and so it should be 4, and then minus and dot 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 so on. So this is our record series. So hope you have understood this. Now let's solve another problem. Now let us solve this question. Here we need to expand this function in Laurent series if mod of z is less than 2 and mod of z is greater than 2 and less than 3. Okay, for these two conditions. So first let us solve it for the first condition. Okay, so first here you see what we're going to do here. So in this case you can see that both the numerator and denominator are of the same degree, because here you see if you multiply z and z, so you're going to get z square. So here also you have z square, so that's why they are of both both of them are of same degree. So that's why what we're going to do, so before we're going to use partial fraction, we're going to divide the numerator by the denominator. So first let me write the given function. So here the given function is f of z, that's going to be equal to z square minus 1, that's equal to z square minus 1 divided by z plus 2 into z plus 3. So if you multiply the denominators as then what you're gonna have, just wait. So first what we're gonna do, let me show here, z square minus 1. If you multiply these two, then you're gonna get z square, then plus 2 plus 3, that's gonna be 5 into z, then 2 3 is 6. That's what you're gonna have. So now divide the numerator by the denominator, and if you do so, then what you're gonna have, so let me divide this z square minus 1 by the denominator, right? Let's divide it by this. So then what we're gonna have, first we're gonna give 1 times, so z square plus 5z plus 6, right? We're gonna consider the positive sign as negative, so these two cancels, positive as negative, positive as negative. So then what we're gonna have here, so minus 5z and minus 6 and minus 1, that's gonna be minus 7, right? That's gonna be minus 7. This is the remainder. So what we can do here, so let me cut it. So that's why we can write here 1 plus, the remainder is minus 5z by minus 7 divided by z plus 2 into z plus 3, right? We can write this way. So hope you have understood this. Now let me cut this, and now here you see we're going to apply a partial fraction here. So let us take minus 5z minus 7 divided by, so let me write here, minus 7 divided by z plus 2 into z plus 3, right? Z plus 2 into z plus 3, right? Z plus 3. So now let us take a by z plus 2 plus b by z plus 3, right? Now let's take LCM, then what we're going to have, z plus 2 into z plus 3, and if you multiply this one with a into z plus 3 into a plus multiply this one with b, then what we're going to have, b into z plus 2 into b. That's what we're going to have, right? So now bz, az, if you take z common from these two, then what you can write, then you can write a plus b into z, then plus 3a plus, that should be 2b divided by this z plus 2 into z plus 3, right? Okay, so now you see if you compare the coefficient of z, this, and on the left hand side this is minus 5, and the constant here 3a plus twice b, and here we have minus 7. So then we're going to have a plus b by is equal to minus 5, and we're going to have 3a plus twice b, that's going to be equal to minus 7, right? So now let's solve these two, and solving these two, what we're going to have, so let me show you here. Now you see you can write b is equal to minus 5 minus a, right? Now let's put that value of b here, 3a plus 2 into b is minus 5 minus a, right, is equal to minus 7, then thrice a, that's going to be minus 10, and minus twice a equal to minus 7, and thrice a minus twice a, that's going to be a, right? And minus 10 on the other side, plus 10, 7 plus 10, that's going to be 3. So we have got a is equal to 3. Now let's put this value of a here, then we're going to have b is equal to minus 5 minus 3, that's going to be minus 8. So we have got a is equal to 3 and b is equal to minus 8. So that's why what we can write, this f of z, this is equal to 1 plus this a by z plus 2, that means a is here 3 by z plus 2, and plus we can write b is minus 8, so b by z plus 3, that is minus 8 by z plus 3, right? Because here you can see this part can be written this way, right? And value of a and b are 3 and minus 8. That's what we have used here. Okay, so hope you have understood this. Now let me copy this function and let me go to the next slide. as we have not enough space here. So this is a new slide, so let me paste here and let me deal with the conditions here, that is z is less than 2. So here is the condition, z is less than 2. So what we need to do here in order to solve this, what we're gonna need, we're gonna need 1 plus x whole to the power minus 1, that is 1 minus x plus x square minus x cube plus x to the power 4 minus x to the power 5 plus dot 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 so on, right? So here to apply this here, that we need to express this denominator in this form 1 plus x, and where x must be less than 1, okay, in order to apply this identity here, okay. So it doesn't mean that here x is always less than 1, but in order to express this in this form, and in order to solve this kind of problem, so in order to express this expression, in order to express this function in Laurent series, we need to arrange this denominator in this form such that x is less than 1, okay. So hope you have understood this. So for this case only we are going to take x is less than 1. So here it is not necessary that x is always less than 1, but for this kind of problems, in order to express this in Laurent's series, we used to do that, okay. That is the method. So hope you have understood. So we have to take z mod of z divided by 2, that's going to be less than 1. So we have to here we have z plus 2. If you take 2 common, here you're going to have 1 plus z by 2, right? 1 plus z by 2, which is less than 1. So we're going to make these things less than 1. 1 plus we must have something that is less than 1. That's the condition, okay. So similarly here z plus 3, if you take 3 common, then what we're going to have z by 3 plus 1, or you can write 1 plus z by 3, 1 plus z by 3, okay. This is also less than 1. If you see if mod of z divided by 2 is less than 1, then it is obvious that z by 3, that's going to be also less than 1, right? So now let's do that. So here you see, let me write this one here. So now we can write f of z is equal to 1 plus 3. So let's take z common, not z common, 2 common. Then we're going to have z by 2 plus 1, or you can write 1 plus z by 2, right? 1 plus z by 2, and plus here you can write minus, because there is minus 8. So minus 8 by, let's take 3 common, then you're going to have 1 plus z by 3. That's what you're going to have. So now you see this can be written in this way: 1 plus 3 by 2, 1 plus z by 2 whole to the power minus 1, and minus 8 by 3, then 1 plus z by 3 whole to the power minus 1. So now let us apply this identity, right? Let us apply this identity, and if we apply that identity, then what we're going to have? Then we're going to have f of z is equal to 1 plus 3 by 2 1 minus z by 2 plus z by 2 whole square plus, not plus, next term going to be minus z by 2 whole cube, then plus dot 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 so on. Then we're going to have minus 8 by 3, and within bracket what we're going to have 1 plus, just wait, give me a second, minus 8 by 3, 1 minus z by 3 plus z by 3 whole square, then minus z by 3 whole cube, and plus dot 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 so on. That's how we can write. Now f of z it can be written this way: 1 plus 3 by 2, so 1 minus z by 2 plus z square by 4 minus z cube by 8 and plus dot 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 so on, and minus 8 by 3, 1 minus z by 3, then plus z square by 9, then minus z cube by 27 plus dot 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 so on. So this is the result. That's how we can find a Laurent series. So hope you have understood this. Now let's move on to the next condition. So before we go to the next part of the next condition, just pause the video and note these things down. Okay, so first note these things, because here you see I'm gonna clean from this part. Okay, because the upper part will be same. For the we are going to solve the same function but for different conditions. So we're going to use here different conditions. That is, things going to be same as it is now. Okay, so just pause the video and note these things. So now what is the second condition? Let me go back to the previous slide. Here you see this is the second condition. Let me copy the condition. This is the condition: z greater than 2 less than 3. So here now let me clean these things first. So what is the condition? This is the second condition, right? So here is the condition, this is the condition. So now let me split this one into two parts, that is 2 less than mod of z and mod of z less than 3, and 2 mod of less than z, that implies 1 less than mod of we should make it less than 1, right? So we can write here z by 2 by z, this is less than 1, and from this part what we can get z by 3 less than 1, right? So hope you have understood this. So now f of z, that is equal to 1 plus 3 by z plus 2 plus let me write here minus simply 8 by, because there is minus z plus 3, right? So here what we're going to do, here you see, in order to get 2 by z, so from here we're going to take z common, right? So let's take z common. 1 plus 3, z is common, then what we're going to get, 1 plus 2 by z, right? So similarly minus 8 by, and from here we are to get this z by 3. So in order to get that, we're going to take 3 common, then we're going to get z by 3 plus 1, so which can be written this way: 1 plus z by 3, right? So now let's just wait, let me copy these things, let me write here. Okay, so now it can be written this way: 1 plus 3 into z to the power minus 1, 1 plus 2 z to the power minus 1 whole to the power minus 1, right? This is 2 by z. 2 by z can be written as 2 into z to the power minus 1. Again we have power 1 here, so if you write this one here, then it's going to be minus 1, power going to be minus 1, right? So hope you have understood this, being a student of BSc, right? So now let me just, okay, let me do a little bit of arrangement here, just okay. Then this part can be written this way, that minus 8 by 3, 1 plus z by 3 whole to the power minus 1. So now let us use this identity. Okay, so then what we're going to have, then we're going to have 1 plus 3 to the power z minus 1, 3 into z to the power minus 1, then within bracket what we're going to have, 1 minus 2 z to the power minus 1, then 4 z to the power minus 2, right? If you expand it, what are you going to have? 1 plus 2 z to the power minus 1, then plus minus 1 whole to the power 1, then next term should be, just wait, that's supposed to be minus, right? That 1 minus z whole to the power minus 1 whole to the power 1, then next term z, not z, that should be 2 z to the power minus 1 whole to the power 2, then minus, and so on, right? And if you expand this series, then you're gonna get, if you simplify it, then you're gonna get this, right? So it's gonna be then 2 cubed, that's gonna be 8 z to the power minus 3, then plus dot dot dot, so on, right? So now let me expand this part. If you expand this part, then what you're gonna have, 8 by 3 1 minus z by 3, then minus, not minus, plus z square by 9, then you're gonna have minus z cube by 27 plus dot dot dot, so on. So that's the series, required series is this. So this is the required series. That's how we can express a given function in Lorentz series. So hope you have understood this. So see you in the next video. Thank you for watching.